Okay, ji, Bismillahirrahmanirrahim. In the previous lecture, we were discussing the Backus NOR form and how it is interpreted between the syntax diagram and the BNF version of a particular syntax related statement for a programming language. Now, let's look at a few examples from your Cambridge exams, and this will give you a good idea of how a particular question is supposed to appear and how you are supposed to solve BNF related questions in your exam. Okay, so this first question, let's look at this first question. As you can see here, the following syntax diagram for a particular programming language show the syntax of assignment statement. We got one syntax diagram for the assignment statement, a variable, and an operator, a letter, an operator. So as you can see here for assignment statement, I have to have a variable. And as you can see here, this is a non-terminal followed by an equal sign, which is here a terminal, then another variable, then operator, then a variable followed by this semicolon terminal. So what that means is that I have a further definition of variable. There should be a syntax diagram for variable, and as you can see here, there is. And there's a syntax diagram for operator. There is one here. But since these are terminals, there is no further definition of what an equal means. Equal is equal, and semicolon is semicolon. It is to be treated like these are. There are no options whatsoever. Okay. Apart from that, we have another definition here that is for a variable. Now, variable can be a letter followed by another letter and another letter. So, from the looks of it, it looks like that if I just want a variable to be of length 1, I can have one letter and I can exit this syntax diagram. And I can also have a 2-letter variable, and then I can exit the syntax diagram. And I can also have a 3-letter variable, and then I exit the syntax. So basically it's giving me option of choosing between a single letter variable, 2-letter variable, and a 3-letter variable. Okay, after that, since letter itself is a non-terminal, so that means there has to be a definition existing for what a letter is. And as you can see here, we do have that. So a letter can be either an A, or it could be a B, or a C, or a D. Same thing goes with operator. Operator can be a plus, a minus, a multiply, or a divide, like so. So this is the syntax diagram as proposed by this problem over here. And this is how you interpret it. So basically, this syntax diagram is saying that if you are using a letter has to be either one of only these 4 options. There are only 4 options for what a letter can be. And according to my programming language, according to the syntax of my programming language that we're discussing right here, whatever it is, there is no such letter as an E. There is no such letter as an F. This language that we are designing only considers A, B, C, and D to be letters, nothing more. Same thing goes with the operator. This particular language only considers plus, minus, multiply, and divide as valid operators. Anything apart from this will not be considered as an operator. And according to my syntax diagram, if this language was ever designed and used, if I chose to write an operator other than these 4, or I chose to write a letter other than these 4, it would generate a syntax error, because according to my programming language, there are no such thing as a letter other than these 4, and there are no such operators apart from these 4. Okay, now let's look at the first part of the question. It is asking us, the following assignment statements are invalid. Okay, so they are invalid, but we have to give the reason why. Give the reason in each case. So in the first statement, we say that A is equal to B plus C. Now, this is a assignment statement. So as per the rule of assignment statement, it should have a variable followed by equal sign, a variable, operator, a variable and a semicolon. Now, as you can see here, I got a variable, and yes, the variable is of a valid letter, yes, and it's of single length, yes, that's agreed. Same thing goes followed by an equal sign, yes, I got that as well. Followed by another variable, b is a valid variable, and it will be of length 1. And plus is a valid operator, that's also okay. Operator is also mentioned perfectly here. And another variable c is also valid because c is a valid letter. The only thing missing here is that I do not have a semicolon at the end. So let's look at C++ for example. C++ is a language that requires semicolon after each line of code. So my C++ compiler knows that this instruction has finished when it sees a semicolon. And if I don't add a semicolon and I move on to the next line, it will generate a next instruction. It will generate a syntax error because it is expecting its compiler is designed in such a way that expects a semicolon at the end. Now, this should make sense to you right now that this language is somewhat doing the same thing. That for this, in this language, an assignment statement has to be completed with a semicolon at the end. So if my compiler is assessing this assignment statement, it will generate a syntax error because it does not have a semicolon at the end. So for this first problem, I will say that the reason that A is equal to B plus C is not a valid assignment statement is because it does not have a semicolon at the end. So for 1 mark, you will just state that the missing semicolon at the end of the assignment statement. Now let's move on to the second statement. Okay, we got A is equal to B minus 2 and ending with a semicolon. So, okay, in this version, we do see a semicolon. So it's correct in that sense, but it does have some problem. That's why it's invalid. Now, so let's start looking at it from the left because that's how the compiler will be looking at it. At the left, I've got a variable as stated here. Variable is of single length and it is a perfectly valid letter. So A, the variable is followed by the equal sign as expected, yes. Followed by another variable as expected, B is an okay variable. Followed by an operator subtraction sign. Is subtraction a valid operator? Yes, it is. We have that here as well. Followed by a 2. Now here is where the problem lies. 2 is not a variable, because of which this assignment statement is invalid. So if I were to answer this question, it would go something like this. You have simply write that 2 is not a variable. Simple. And as we can see here, for this, it was the assignment. The semicolon is missing at the end of statement. Okay, now let's look at this third one. We've got a variable, okay, A is a variable followed by the equal sign, that's as expected. Then we have a variable with 2 letters. Now, is this a valid variable? Can D with 2 D's be considered a variable? Is D a letter? Yes, it is. Can I have a letter of 2? If I can I have a letter of length, can I have a variable of 2 letters? Yes, I can. So that means this part is okay. DD is a valid variable. What about the multiplication sign? Is it a valid operator? Agreed. It is a valid operator. So yes, we will take this as a valid operator. Followed by CCE. Now I've got a variable here of length 3. Can I have a variable here of length 3? Yes, I can. And does it have a semicolon at the end? Yes, it does. So what's the problem here? The problem is that E is not a letter. According to my syntax diagram, letters start from A and end at D. So E is not a letter. And since E is not a letter, CCE is not a valid variable. So how do we respond to this question here? We'll simply write E is not a letter. E is not a letter. So questions like this should be responded in this manner. Now, the next part is requiring us to write the Backus norm form for the syntax diagram shown on this page. So let's check out the first part. As you can see here, the first part, assignment statement, is defined by, is already mentioned here. So I have to simply just proceed towards the optional parts if there are any. So let's see what we can do for that. So assignment statement is defined by a variable followed by an equal sign, followed by a variable, followed by an operator, another variable, and a semicolon. So by that logic, my answer should be something like my answer should be variable. Now notice that I have mentioned these symbols here because as per the syntax diagram, variable here is a non-terminal. So if you remember that variable any non-terminal in Backus norm form has to be enclosed in this symbol. So followed by equal sign. Equal sign will remain as it is. So I don't need to add, because equal sign is a terminal. I don't need to add any non-terminal symbol over here. Then followed by a variable again, like so, followed by operator, like so, followed by another variable, like so, and then we got a semicolon at the end. So according to this syntax diagram, variable is equal to variable operator, variable semicolon. So variable assignment statement is defined by variable is equal to variable operator, variable semicolon. So yes, this is the syntax, sorry, BNF representation of this syntax diagram used here. Let's check out the second part. It's asking me the Backus norm form of what a variable is. Now, if you pay close attention, this is not a variable of any length of letters. So in the previous lecture, we discussed how a loop is implemented and how we can make sure that something can be of any length of characters. This is not the case here. This particular variable is not allowing letters of any length. It is only allowing letters of up to 3 letters. Up to 3, only length up to 3. So you can have a variable of length 1, 2, and 3, no more. So in that case, we cannot use the loop here. There's no unlimited length here. We only have 3 options. So in that case, we can do what? Letter, single length, followed by this. Remember this symbol? This is OR. This is the OR symbol in Backus norm. And I can have a letter of length 2, like this. Two length letter. And then also a variable of 3 letters. Like this. So according to this syntax diagram, I'm allowed either a single length letter, a double length letter, or a triple length letter. Similarly, how do I take care of the Backus norm form for what a letter is? Now, if you if you look at this closely, there are no non-terminals in this definition. So I will not be using that symbol over here. All of these are terminals. So a letter is defined by either a or a B or a C or a D. That's it. A or B or C or D. Same thing goes with operator. Operator is defined by a, sorry, either a plus sign, either a minus sign, either a multiply sign, or either a divide sign like this. Oh, you should use the symbol for division as it's intended. So I'm since writing this on PDF, adding that symbol is not straightforward. So you can just, I'm just replacing that, but do not make this mistake. If you're using divide symbol here, you will use divide symbol here as well. Please take note of this, that division sign, whatever signs you're using here, should be used here as well. So right here, for example, your answer should look something like this. I should have, in fact, the division sign here. Instead of this, I should have the division sign like this. So plus, minus, multiply, and divide. The exact symbol that was used over there. Like so. So that is the Backus norm form for operate. Okay. Now this part C says, rewrite the BNF rule for a variable so that it can be any number of letters. So now this is basically modifying this Backus norm form to allow for any number of letters. Currently, my variable definition allows for only up to 3 letters. But if I want any number of letters, that means that now I will need the loop structure. The way that we have used in the previous lectures, we'll be applying that over here as well. So now, if you remember that what we said was that a variable can be a length 1, and a variable can be of any length of letters. So the definition, by the way, this is a non-terminal, and also variable. Now, if you're not remembering what's happened here, how this rule comes about, I'll revise this over here. So let's just say that I want a variable length of, I have a variable of any length. So I'm allowed, say, 4 letters, A, B, C, D. This is one variable of 4 letters. Previously, I had an option of going for only 3 letters, but I can go for 4, 5, 6, any length I want. So this particular variable is of length 4. Now let's see how this rule can be, this rule satisfies this variable, or this variable satisfies this rule. So as the language translator will do, I will start reading from the left. Is this a letter? Is a letter? Yes, it is. So if I just look at this letter alone, this letter, single length letter is actually a variable. So based on this part of my variable rule, I can say that A is a variable just because of this part of the rule. So A alone is a variable. Okay, now let's look at these two. I just established that A is a letter, and this part of the rule says that, sorry, A is a variable. I just established that A is a variable considering this part of the rule. Now, this part of the rule says that a letter can follow a variable and it will still be considered as a variable. So that means if A is a variable, and B is following A, that means AB is collectively also a variable. And then if AB has been established as a variable, ABC using this rule, AB is a variable followed by another letter is also a variable. ABC will also become a variable. And again, following by the same rule, if ABC is a variable can be followed by a letter, and if D is a valid letter, that means collectively ABCD is a variable. And I can add any letter, any number of letters, provided that they are of the valid type of letter A, B, C, D, any length of letters, and I will keep on using this rule and making and proving that these are all valid variables. So whenever you want to make something of any number of letters or unlimited length or no defined length, this is how you're basically implementing a loop, and this is how a loop is implemented in your Backus-Moore form.